Hello everyone. In this lecture, we will see the sum of product, product of sum, and canonical form of SOP, canonical POS form, and then we will see the minimization. That means a simplified SOP and simplified POS. So first we are starting with a SOP. Now we can classify SOP as two parts. First one is the canonical and standard form. So sometimes it's called as the canonical, sometimes it's also called as the standard form of SOP. And another one is called as the minimized SOP. So now we will start with the canonical form. So canonical or standard form of SOP, canonical form of SOP. So a binary variable may appear either in its normal form, either, for example, I'm considering input X. So that binary variable can be appear as X or it can be appear as a complement like X bar. Now consider two variable. For example, I'm considering X and Y are my inputs. And if we combine by using the AND operation, since each variable may appear either in its normal form or in its complement form, there are total 4 possible combinations. Right. That means either you can write down X bar, Y bar. This is the 4 possible combinations. I'm writing X bar, Y, and then X Y bar. And then this is the 4th combination, that is X Y. Right. Canonical form means what? Each term should have all the literals or variable. Then it is called as the canonical form. If I write any expression y is equals to X bar Y plus X Y bar plus X Y, for example. As you can see, it's having the 3 terms, first term, second term, and third term. If each term, I'm talking about this is first term, this is second term, this is the third term. Each term should have all the literals or variables, input variables. How many input variables are there? We have X and Y, right? X and Y are my input variables. X comma Y are my input variable. Now you see in each term, this is the term. So here in this term, we have X, Y. In this term also, we have X and Y. In this term also, we have X and Y. That means if all the terms, each term is having all the input variable, then it is called as the canonical form. Simple. Right? Now, how to write down the expression? Always remember the canonical SOP. I'm talking about canonical SOP. Canonical SOP is written only when your function value is equals to 1. When function value equals to 1. In case of canonical SOP, the function value should be 1. Another thing, the 0 is the complemented form. 0 is the complemented form and 1 is called as the normal form. I will tell you why I'm writing like this. For example, I have any truth table with us. Okay. X, Y, Z. As I'm taking 3 input variable, how many possible combinations are possible? Total 8 possible combinations. 0, 0, 0, 0, 1, 1, 1, 1, 0, 0, 1, 1, 0, 0, 0, 1, 0, 1, 0, 1, 0, 1. For example, I have the function output and which is written as 0, 1, 1, 0, 0, 0, 1, 0. For example, it's written like this. Now we have to write down the canonical SOP form. Okay, how we can do that? As in the first line I have written, the canonical SOP form is written when the function value is 1. That means I am making the circle here. This is function value 1. This is the function value 1. And this function value 1, right? Now we have to write down the expression of f whenever function value is 1. That's okay. Now here you see f. After that, I have written that 0 is the complemented form. 0 is the complemented form. That means if your input is x, complemented will be represented as x bar. And 1 is the normal form. That means if I write x is my input, then x will be the normal form. So now here I am to write down the function value when your function value is 1. This is the expression when x is equals to 0. 0 means a complemented form, so we can write down as x bar. Y is 0, so y bar. Then 1. Z is equals to 1, so z. Clear? 1 means a normal form, 0 means a complemented form. That's why y bar, 0 is the complemented form, so x bar. Now again, function is 1 for this condition, and that will be clubbed with the OR operation. That's why it is called a SOP. This is the product, and we are taking the sum between it. So now this is what x bar, y, z bar. Clear? Why? Because x is 0, so complemented. Then 1, y is equals to 1, so the normal form. Z is equals to 0, so complemented form. Similarly, the third time function value is 1. That means it's having the 3 terms. Now x is equals to 1, right? So it's normal form. Y is equals to 1, so normal form. Z is equals to 0, so complemented. This is what a canonical SOP form. This is the canonical SOP form. I hope it's clear that function, that SOP, canonical SOP will be written when the function value is 1. Now, for example, I am taking another example. For example, I have any expression y is equals to a b bar plus bc, for example. And question is what? We have to check whether it is a canonical form. If not, then find out its canonical form. So now first a definition says that to be a canonical form, each term should have all the input variables. So here you see this is the first term, this is the second term. In the first term, C is missing. Right here I'm writing C is missing. Similarly, in second term, A is missing. And by the definition of canonical form, we know that if for the canonical expression, each term should have all the literal. But here, C is missing in the first term and A is missing in the second term. That means we have to include C and A in the first and second term to make it as a canonical form. So how we can do that? To convert into the this is of course SOP. Okay, this is the sum of these products. So that's why it's a SOP, but it's not a canonical SOP. Okay, so here we need to convert into the canonical SOP. How we can do that? Y is equals to A, B bar. As C is missing here, we can include it like this, C plus C bar, because it will not change the functionality. C plus C bar is equals to 1, and 1 dot anything will be anything. Okay, so it will not change the functionality. Here also, as A is missing, we can include as A plus A bar, BC. If you open this expression, you will get A, B bar, C plus A, B bar, C bar plus A, B, C plus A bar, B, C. Clear? So that is how we can find out the canonical expression. So this is the canonical SOP. This is the canonical SOP. Now we will see. I'm making another question. For example, we have a truth table with us, and this is written as X, Y, Z, for example. And as we have the 3 input variables, total 8 possible combinations will be there. 0, 0, 1, 1, 0, 0, 1, 1, 0, 1, 0, 1, 0, 0, 1. Now here, for example, the expression is given as like 1, 0, 0, 0, 1 0 0 1, for example, like this. And we need to write down the canonical expression. We already solved this type of questions earlier, so we can directly write down the expression here. So f will be written when the function value is 1, because we have to write down as a canonical SOP. Canonical SOP form. Right. So this is written for these expressions. So what is that? This is x bar, y bar, z bar, because all are 0, 0, 0, and 0 is represented by its complement form. Similarly, here you see plus x, y bar, z bar, because x is 1, y is 0, and z is 0. Similarly, plus x, y, z. So this is the canonical SOP. Now we have to write down in terms of minterms, right? So let's see what is the meaning of minterm. Minterm is written for SOP only, and this is actually the decimal representation of binary combination. Minterms means the decimal representation of binary combination. So here I am writing the minterm. So minterm says that it is represented by small m. 0, 0, 0 in decimal meaning 0, m0. 0, 0, 1 decimal meaning is 1. 0, 1, 0, 2. So it is m2. 0, 1, 1 that means 3. So this is m3. That means what? This is the decimal representation of this binary combination. This is what? m4. This is m5. This is m6. And this is m7. Right. So this is the canonical SOP. We can also represent the function as the sum of product, and the symbol is used is summation. Inside the bracket, we have to write down the minterms, right? So function is 1 for m0. So here you write down m0, comma. Second time it is 1 for m4. So you can write down m4. Third time it is for m7. So you can make it common m7. The same formula also can be written as only with the terms like 0, 4, and 7. So this is the 3 ways by which you can write down the canonical SOP. This is the logical expression. This is the formula. These are the formula forms. Okay. So canonical SOP min terms are interrelated. Now we will see the canonical POS form. Okay. First we will see the minimal SOP form. So for example, we have written this expression by 0, 4, 7, right? So for example, we got this expression. This is the canonical expression. F is equals to this one. Now you see F is equals to x bar, y bar, z bar plus x, y bar, z bar plus x, y, z. For example, we have this expression and we need to minimize it. So how we can do that? You see, if I take x here, I will take y bar, z bar common. So it will be x bar plus x. This is y bar, z bar plus x, y, z. So this will become y bar, z bar plus x, y, z. Correct? So this is the minimal SOP form, because this is already a SOP and we have minimized it. So this is called as the minimal SOP form. Correct? So we have seen canonical SOP. That means each term should have all the literal. If you are minimizing by using the theorem or by using the K-map, that expression is called as the minimal SOP form. After this, we will see the this POS form, product of sum form. POS or product of sum. If I am writing any expression like y is equals to a plus b bar and like b plus c bar, this is called as the product of sum. Why? Because we are taking the sum and then we are taking the product. So it is called as the product of sum. Again, here we have two parts. One is the canonical or standard POS form. Another one is called as the minimal SOP, minimal POS. So let's start with the truth table, and we will start with the canonical POS form. So this is the canonical POS form. Canonical POS form can be understood from the truth table first. So here I am making X, Y, Z. As we are taking 3 inputs, so total 8 possible combinations will be there like this. For example, function value is also given to us. For example, 0, 0, 1, 0, 1, 1, 1. See, for example, like this. So always note down these two important points. What is that? The canonical POS is written when your function value is equals to 0. Function value equals to 0. That is the first point to remember. Always the canonical POS form is written when the function value is 0. Here, 0 is the normal form. Again, the second point. And 1 is called as the complement in case of POS. So now here we can write down the expression f for these condition when the function value f is equals to 0. Right? Function value 0 here, 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 and here. 0 is the normal form. That means I have to write down as x plus y plus z because this is the POS form. 0, so normal form. Y is equals to 0, so normal form. Z is equals to 0, so normal. Then dot operation. Second time the function value is 0 for this condition. X is equals to 0, so x. Y is the 0 is the normal form, so y. Z is equals to 1 is the complement form, so z bar. Dot. Third time it is 1, it is 0 for this condition 0, 1, 1. So you can write down as x plus y bar plus z. Why? Because 1 is the complement form and 0 is the normal form. Dot operation, fourth time function value is 0 for this condition when the x, y, z is equals to 1, 1, 1. So you can write down as x bar plus y bar plus z bar. So this is what a canonical POS form. Okay. Now this canonical POS form can also be interrelated with a max term. Okay. So this is related with max term. Again, this is nothing but a decimal representation of a binary combination, and it is represented by the capital M. So it is what M0, this is M1, this is M2, this is M3, this is M4, this is M5, this is M6, and this is M7. So we have written the canonical POS expression. There is another way by which we can write down this function f, that is the formula form. As this is a POS, the symbol used is the product pi. Inside that you have to write down the max terms where your function value is 0. So 0 for this condition, this is 0. Second time it is 0 for M1. So this is 1. Then it is 0 for 3. So here you write down 3. Again, it is 0 for this 7. So it's 7. Clear. So this is how we can represent a canonical POS in the normal Boolean form or by using the theorem. This is called as the canonical POS. But what will happen if you what is the definition of minimal POS form? For example, I have any expression like pi, and it is given as 1, 2, 3, 5, for example. And question is what? First write down the canonical POS form and then you find out the minimal POS form. How we can write down the canonical POS form? So for canonical POS, it is 1. How we can represent 1? 0, 0, 1. Right. Next term is 2. I can write down as 0, 1, 0. Next term is what? 0, 1, 1. Next term is what? 1, 0, 1. As this is a POS form, 0 represents the normal form. right? And 1 will represent the complement. So as it is a 0, 0, 1, I can represent as A plus B plus C bar, right? Dot operation. 0, 1, 0. So 0, 1, 0, that means A plus B bar plus C. 0, 1, 1. So 0 means what? A normal form. So you can write down as A plus B bar plus C bar. Next term that we have is what? Is 101. So 101 means what? A bar plus B plus C. Correct? Now you see we have to minimize because this is the canonical POS form. F is equals to this one. But now we have to minimize it. Minimal POS form we need to find out. So you see if you combine these first and A plus B. So these two we can minimize and these first and fourth we can minimize. So from first and fourth, if you see uh, from see so between these two, if you see, so I am taking A plus B bar as a term. This is a common term. And then we are having C bar. So this is between this 2 and 3. And this is 5. And okay, this is 1, 0, 1, 0. Okay. And another one is this one, right? So we can take B plus C bar common. So here I'm taking B plus C bar common. And later we have A bar. So now this is what? A 0. So you will get B plus C bar. C bar is also 0. So you will get A plus B bar. So this is a POS, but a minimal POS form. Minimal POS form. So we have seen how to write down the canonical SOP. Then we have seen minimal SOP. Then we have seen canonical POS form. Then we have seen minimal POS form. Let's see one numerical, and then that concept also will clear how we can find out if the SOP expression is given, how we can find out POS expression. That also we will clarify. So let's start one question. Uh, For example, they have given F is equals to summation M. This is for sum of product 0, 1, 6, 7. Okay. And the question is what? Write down the canonical SOP form. Then you write down the minimal SOP. Then you find out the canonical POS form. And then you write down, find out minimal POS. Let's see how we can do that. So to write down the canonical SOP is very easy because sum of product form is already given to us. And F, we know that as this expression is the sum of product, right? So this is 0. So how we can represent in the 3 bits, because the 7 is the largest number that we can implement by using 3 bits. So 0 can be written as 0, 0, 0. 1 can be written as 0, 0, 1. 6 can be written as 1, 1, 0. And 7 can be written as 1, 1, 1. In the SOP form, 0 represents complement and 1 represents normal form. That means it is A bar, B bar, C bar plus A bar, B bar, C plus A, B, C bar plus ABC. I hope this is clear, right? So this is what called as the canonical SOP form, right? Now, if you see, we need to minimize the expression, right? And find out the minimal SOP form, F. So here, if you take A bar, B bar common, C plus C bar will come. Similarly, in between these two, A, B, C plus C bar. And we know that C bar is equals to what? 1. So that will become A bar, B bar plus AB. And that is actually the minimal SOP expression. That was the canonical. And this is the minimal SOP. Minimal SOP. Now question arises that the expression is given in the terms of SOP and they are asking the expression as a canonical POS form. So how we can do that? So as we know that the SOP is written when the function value is 1. That means whatever terms are missing for them, function value will be 0. That means if I have to write down in the formula form, I can make one pi. And whatever terms are missing here, I will write down the bracket. Right. So here that like 2 is missing, 3 is missing, 4 is missing, 5 is missing. So for these terms like 2, 3, 4, 5, it is a max term. That means where the function value is equals to 0. So now I got the expression and we can write down the canonical POS form. So now here f is given as 2, 3, 4, 5. Right. That we have seen whatever terms are missing here, like here. So that will indicate when their function value will be 0. Okay. Now we can write down this term that is 0 because 2 it is 2. So 0, 1, 0. 3 means 0, 1, 1. 4 means 1, 0, 0. 5 means 1, 0, 1. In the POS form, 0 indicates the normal form and 1 represents the complement form. So here it is A plus B bar plus C, A plus B bar plus C bar. This is A bar plus B plus C. This is A bar plus B plus C bar. Right. Okay. So now we got the expression. This is called as the canonical POS form. So this function is what? Canonical POS. Okay. But we need minimal POS also. That means we need to minimize this expression by using the theorems. So here if I take A, B bar common, that is okay. Plus by using the distributive property, C, C bar, right? Similarly here A bar plus B plus C, C bar. C, C bar is equals to 0. So you can write down as A, B bar and this is A bar plus B. So this is the function value. So we have seen by using any equation, whether it's SOP or PS, we can find out canonical SOP, canonical POS, minimal SOP, minimal POS form. Right. Now, if I ask one question, like they have given some minimal SOP form, like F is equals to A B bar plus B C bar, for example, like this. And this is actually a SOP expression. And the question is what? We have to find out the canonical SOP. Canonical. Canonical SOP. So whatever terms are missing, you include it. F is equals to. This is A, B bar. Here C is missing, so we can include it like this. Here A is missing, so I can include it like this. A, C bar. So now this has become A, B bar. Right. Now C plus A, B bar, C bar plus A, B, C bar plus A bar, B, C. So this is the canonical SOP. Sometimes what happens? They give SOP expression like F is equals to A plus B, C bar. And question is what? This is the SOP, correct? This is the SOP sum of product. And question is what? Convert into the POS. How we can do that? F. By using the distributive property, we can write down A plus B, A plus C bar. So this is called as the PS. Now, if the expression is given like this, F is equals to A plus C, A plus B, A bar, for example, like this. And the expression is in the POS, right? This is the expression in the POS. And the question is what? Write down its SOP expression. So simple is what? Open the bracket and do the logical multiplication and addition. So A plus A bar, A dot A bar plus AB, right? A bar, AB plus A bar C, A bar C plus BC. A bar is equals to 0. So you can write down as AB plus A bar C plus BC. This is what SOP expression. So if the expression is in the SOP, you can find out POS. If the expression is in the POS, you can find out the SOP. Right. Min term is associated with SOP. Max terms are associated with the POS. I hope the concept is clear. The last question we are taking, and this question you try by your own, like X, Y, Z. And we have expression F. This is as we are having three inputs, so three input variables. So there will be a 8 possible combination like this. So 0, 1, 1, 0, 1, 0. F 0, 0, 0, 1, 0, 1, 1. For example, this is the truth table. And first you have to write down the canonical SOP form, for example, how we can do that. So F, wherever your function value is 1, right? So here function value is 1, here is 1, here is 1, here is 1. So how you can write down? This is X bar Y Z, because for this expression, plus for this expression is what? X Y bar Z plus X Y Z bar plus X Y Z. So this is what a canonical SOP. I hope this is clear to you, right? So this is the canonical SOP. Now by using the theorem, we can minimize the expression, right? And that will be the minimal SOP form. From these two, you can take XY common, that will give you ZZ bar as 1, right? And from these two, you can take Z common, and that will give you XOR operation. That will be the another. Similarly, if I ask you to write down the canonical POS form, how you can do that? So for the canonical POS form, write down the expression when the function value is equals to 0, right? And 0 represents the normal form and 1 represents the complement form. These two things is very important. How we can write down here is what? X plus Y plus Z, X plus Y plus Z bar, X plus Y bar plus Z, and this is X plus X bar Y plus Z. So this is the canonical POS form, and by using the theorem, you can minimize it. That will give you the minimal POS form. So this is the way. And here also you can write down the min terms. As I told you, min terms is nothing but a decimal representation of a binary combination. So this will be M0, this is M1, this is M2, this is M3, this is M4, this is M5, this is M6, this is M7. Similarly, if you want to write down the expression of SOP in the formula form, you can write down as F is equals to summation. So you can write down in the formula form like this. 1 for this condition, this is 3, this is 5, then 6, then 7. This is the canonical formula form. Same thing you can do with a POS form. For F is equals to make a pi, for which their function values are 0, like 0, 1, 2, and 4. So this is the canonical POS formula. That's all for this lecture.